We've seen two previous examples of chi-squared, and at this point we understand that chi-squared is the procedure that you use to run a test on categorical variables. Okay, so we've looked at chi-squared goodness of fit test, which is where you basically have one categorical variable and you're trying to see if what you observe fits what you expected it to be, hence the name goodness of fit. This type of chi-squared test is a chi-squared test for association, also called test for independence. This is when you have two categorical variables, so like a two-way table. And it's used to determine whether there is a significant association between the two variables or whether they're independent or dependent. Okay, the way you would write your hypothesis here, your null hypothesis is that there is not an association. So think about the way we've phrased things in the past. Like when we're doing means, your null hypothesis would always have an equal sign in it. When we did the goodness of fit test, we wrote it in words, but our null hypothesis was always same. Well, remember, another way of saying equals is same. Another way you could say it is no difference. Okay, so that's basically what you're saying here. Your null hypothesis is there is no difference between these two variables, or there is no association between these two variables. They're the same. Right? Then your alternative hypothesis is that there is a difference, or that there is an association. Okay, so your null hypothesis is no association, which means that they would be completely independent of one another. And your alternative hypothesis is that there is an association, which means that they are dependent on one another. As far as the formulas go, the chi-squared formula is the exact same as we saw for the goodness of fit test, but one difference is the expected values now that we will be working with a two-way table. You also see a difference in how the degrees of freedom is calculated. It's not just the number of categories minus one, because you have two categorical variables. So you'd have to do the number of categories minus one for both of your variables. Okay, now these two are on your formula chart. This one is not. Okay, so we do need to memorize how to find our expected values. All right, let's go through an example. Do these data provide convincing evidence of an association between anger level and heart disease for people with normal blood pressure? So take a look at the data first. We're dealing with categorical variables. In fact, we're dealing with two categorical variables. One, do you have heart disease? Yes or no? So these people, yes, they have coronary heart disease, and these people do not have coronary heart disease. And then the other variable we're looking at is your anger level. So low anger, moderate anger, or high anger. So we have these two variables, hence the two-way table. There are no percentages that we're comparing it to. We're comparing these two variables to each other. And that's what indicates that you want to do a chi-squared test for independence or association. All right, so null hypothesis. You're always assuming that there is no difference, or in this case, that there is no association between anger level and heart disease, which just essentially means that these two variables are independent of one another. What we're trying to prove is that there is an association between anger level and heart disease. So we're trying to prove that they depend on one another. You know, like maybe angry people have more heart problems, or less angry people have fewer heart problems. That sort of thing is what we're trying to prove. All right, so let's run through the math here. The table that we were originally given represents our observed values. And when we get our observed values, one of the first things you need to do is calculate the totals. Like if you remember when we did the goodness of fit test, when we did the traffic stop problem, the first thing we did was calculate that there were 192 total traffic stops, and from there we could get our expected values. Same thing with the births example that we did. I needed to know that there were a total of 140 births in order to get my expected values. So here I need to get my totals, and I need to do my totals for each row and for each column. So like I see here that there are a total of 3,110 people with low anger, 4,731 people with moderate anger, and 633 with high anger. Now do that across each row. We have 190 people with coronary heart disease. And we have 8,284 with no heart disease. And that gives me a grand total of 8,474. Okay, so now that we have our totals, we can come down here and calculate our expected values. So your expected value, remember from the previous slide, you're going to do your row total times your column total over your grand total. All right, so for this first cell here, for the low anger with heart disease, my row total is 190, and the column total is 3,110 over the grand total 8,474. So I would expect 69.7 people to fall into that category. All right, now we're going to do the same thing going across here for moderate anger. This whole row has 190 people with heart disease. The column has 4,731 people with moderate anger, and that is out of an entire sample of 8,474 people. So we would expect 106.1 people in this category. All right, now we're going to keep going all the way across. So for high anger, the whole row is 190 people with heart disease times 633 people with high anger out of 8,474. I'm going to go back and calculate those when I can just kind of type stuff in my calculator quickly. I'm going to go ahead and write down the math for the second row. When you move to the second row, now you're moving to this. So you have 8,284 people without heart disease times your column total. I'm back to the low anger. My column total there is 3,110 out of your grand total, 8,474. All right, when you move to the next one, your row total is still 8,284, but now you're looking at the moderate anger column, 4,731 out of your grand total. And for the last cell here, you have your row total for the row that we're looking at times your column total for the people with high anger over their grand total. So I'm going to type those up in my calculator so I can fill those in. So here I expect 14.2 people. Here I expect 3,040.3 people. Here I expect to have 4,624.9 people. And in the last cell, I would expect to have 618.8 people. Okay, so that's how you find your expected values. You do the row total times the column total out of the grand total is how many you would expect to find in each one of those sections. All right, now for the chi-squared formula. So remember chi-squared, you do observed minus expected squared over expected. We have our observed values, we have our expected values. Now we're going to go through and use this formula. So I'm going to write the formula first and then go back and fill in the math. So here we observe 53 people, but we expected, so we observed 53 people, we expected to have 69.7 people squared over 69.7. In the second one, we observed 110 people, but we expected to have 106.1 squared over 106.1. Next, for high anger coronary heart disease, we observed 27 people, but we expected to have only 14.2 people, squared over 14.2. Moving to the second row, we observed in this cell 3,057 people, but we expected to have 3,040.3 squared over 3,040.3. Next, we got 4621 minus the expected value, 4624.9 squared over 4624.9. And last, we have the observed value, 606, minus the expected value, 618.8, squared over 618.8. All right, I'm going to type these into the calculator. I'm getting 4.0, 0.1, I'm just using one decimal place here, 11.5, 1, 0.003. I can't even do one decimal place. That one's so tiny. And last, 0.3. Okay, whew, that is a lot of work. If you tune in to our tutorials, I will show you how to do all of that in the calculator so you don't have to do any of the math. All right, so let's see what we got here. Our test statistic, if we add all of these up, 4 plus 0.1 plus 11.5, ooh, that was a big one, plus 0.1 plus 0.003 plus 0.3, we get 16.003. Now let's compare that to our critical value, so degrees of freedom, and then we need our critical value here. So degrees of freedom, we did earlier, the number of categories minus 1. The difference is we have 2 variables. So here we're going to have to do 2 minus 1. And across the top, we're going to have to do 3 minus 1. So 2 minus 1 is 1. 3 minus 1 is 2. So 1 times 2 is 2 degrees of freedom. So we're going to go on our chart and we're going to use a significance level of 0.05. So 0.05 with 2 degrees of freedom is 5.99. And remember what that 5.99 looks like. If you draw a little pi-squared chart, starts down here at 0, 5.99 tells me that from here down is a probability of exactly 0.05. Well, our statistic, 16.003, would be further down here. So if from here down is exactly 0.05, then from here down is very, very, very tiny, much smaller than 0.05. And we know that when P is low, reject the hoe. So our null hypothesis was that there was no association, and we were trying to prove that there is an association. So if you reject the null hypothesis, that means you have evidence to conclude that there is an association between anger level and heart disease. That means your anger level depends on heart disease, or vice versa would probably sound better. That your heart, whether or not you have heart disease, depends on how angry you are. Don't confuse that with causation. It doesn't mean that heart disease is caused by being angry. Maybe people are just angry because they have heart disease. I don't know. We can't say that one causes the other. We just know that there is some kind of link between the two. Yeah, that was a very, very, very long example. There is a much faster way to do it in your calculator. So if you tune into our virtual conference, I will be more than happy to walk you through how to do all of that stuff in the calculator so that you can do it in a matter of a minute or two.